Hello, my name is METİN Arıdaşır. This is 269th part of explanation of my theory. According to my theory and my formulas, how the electrons differentiate when they meet proton chain to build an atom. Electron differentiation to build an atom. Differentiation of electrons to form an atom by establishing bonds with proton chains. Note, in accepted physics theories, electron is a dimensionless point particle and electrons are indistinguishable and identical to each other. If that were the case, atoms wouldn't have different fingerprints. According to my theory and my formulas, 1. There are various types of electron motion form in our universes according to different wavelength sizes. By the way, don't forget, as I told you before, giant electron motion forms, in other words, black holes with wavelengths of hundred millions of kilometers are also included in different types of electron motion forms. The most common type of electron motion form in our universes is electron motion form with a wavelength 91.155 nanometer when they are free. Yes, here protons. One proton, two protons chain, 3 protons chain, 4 protons chain. The most common type of electron motion form in our universes is electron motion form with a wavelength 91.155 nanometer. When these types of electron motion forms encounter here protons, okay. When these types of electron motion forms encounter proton chains, not strike, only meet and make joint cyclical motion with proton. Electron motion forms when they were free before building an atom with connecting with protons, they were 91.155 nanometer wavelength size. Yes, but when they encounter to make joint motion, each one by one. One electron, one proton, one electron, one proton. Okay. When these types of electron motion forms encounter proton chains, they differentiate and form atoms. When these type electron motion forms meet proton chains, they differ depending on the number of protons. As the number of protons in an atom changes, the wavelength, volume of each proton-bound electron motion form changes again. For instance, to me, neutrons are agents shadowed by two entangled electron motion forms in the atoms. As soon as these two entangled electron motion forms separate from each other, the shadowed proton emerges and becomes active. So the electrons have different values again, and a different and new atom emerges. Yes, when these types of electron motion forms encounter, say this electron motion form encounter only one proton. Exception. Here, no change, okay? Again, 91.155 nanometer. Lambda normal, initial wavelength. This is what? Hydrogen atom, okay? Here, and its point energy is ionization energy, ground state energy. What do you say? Whatever you say, what 21.78 10 to the minus 19 joules here. But if, for instance, this free electron motion form 91.155, this is a proton chain. This is a proton chain. Okay. Now there are two protons. Here, these two protons connected with each other. Joint motion. They made joint motion with each other. Here. When this electron motion form meet this only single proton, there is no change. But, for instance, if this electron motion form, free electron motion form, most common type electron motion form in our universes, 91.155 nanometer wavelength size electron motion forms, when this encounter meet this proton, what will be done? Here, first electron motion form will change its wavelength under the effect of a proton, because there are two protons. Okay? Like what? Here. This is this 91.15 nanometer wavelength size free electron, when it encounter meet and when this free electron motion form makes joint motion with a proton, which sides it's not important, shrinks in proportion squared number of proton shrinks to what? 22.78 nanometer. Okay, shrinks. Inversely proportional to, I'm so sorry, inversely proportional to proton number. Like this. Remember from my former video, proton number squared, don't forget this. nanometer. Another one, 50.40, another electron motion form. If another free electron motion form meet this proton chain, after this will come, make joint motion. Okay, this one in this direction, but this one say up direction. 50.44 nanometer. Again, it changes its wavelength. Not always shrinks. Sometimes here another sample maybe greater than 91.155 nanometer initial size. But always first electron motion form when meet a proton chain shrinks at this rate. Okay, don't forget this. Here, 3 protons connected with themselves, proton change. 1, here 1, 2, 3. Okay. Say here again 91.155 nanometer free electron motion form. When one of these meet this 3 proton chain, okay, what were our formula? This is smallest wavelength size electron motion formula that I put forth in an atom. Okay. Here, what will be? (91.155) divided by 3 square is equal to here it will come and meet and encounter and make joint motion here or there. It's not important. Say here. Okay. 10.12 nanometer. It will shrinks under the influence of this proton chain. Yes. Second electron will be, I have computed according to my theory and my formulas, will be 16. Here second. I'm so sorry. This direction, this is this direction, this is this direction. What will be its wavelength size? It shrinks to 16 nanometer. And here, last one, when encounters like this here, a huge electron motion form, 229 nanometer, 229.97 nanometer change. Because electron motion forms are three-dimensional and they have adiabatic inner and outer medium. Okay, like this. So important. The most common type of electron motion form in our universes is electron motion forms with a wavelength 91.155 nanometer. When these types of electron motion forms encounter proton chains, they differentiate and form atoms. This is hydrogen atom, one proton. This is what? Helium atom. This is lithium atom. Okay. This is if these three electron motion forms come, meet, and encounter and connected with these four protons. This will be what? Beryllium. I guess beryllium atom. So on and so forth. Okay. The most common type of electron motion form in our universes is electron motion form with a wavelength 91.155 nanometer. When these types of electron motion forms encounter, not strike, make joint motion. Here, this is this direction, and this direction, joint motion. First proton, 22, electron motion form shrinks, this direction, second, this direction, lithium, first, this direction, second, this direction, opposite directions, third, this directions, okay? Different, up and side. What associate Pauli extinction, what principle? But this is real reason of up and down. Okay, that I put forward. When these types of electron motion forms encounter proton chains, they differentiate and form atoms, different atoms. Okay. When these type electron motion forms meet proton chains, they differ depending on the number of protons. As the number of protons in an atom changes, the wavelength, volume of each proton-bound electron motion form changes again. For instance, to me, neutrons are agents shadowed by two entangled electron motion forms in the atoms. As soon as these two entangled electron motion forms separate from each other, the shadow proton emerges and becomes active, so the electrons have different values again, and a different and new atom emerges. What we say, transmutation of an atom, that I put forth. It's theory. I remember transmutation of an atom. Okay. There is no electron motion form roaming free in an atom. Each electron motion form must be bound to a single proton. In doing so, the wavelength, volume of each electron motion form changes to be different from that of the others. This is the reason for the different ionization energies in an atom. Each ionization energy in an atom represents an initial specific wavelength of a proton-bound electron motion form. Here, one proton, no change. 21.78 10 to the minus 19 joule. It's point ionization energy. Here, helium. Two ionization energies. This one smallest, the highest ionization energy, 80